So the project was due at 9 this morning. Huh? It was. My little tippy-typey fingers got sore. I think it's entirely likely that some of you got near the finish line but didn't quite make it. I was looking at, so there are two settings that I can set on an assignment for, oh hell, let's just look at it. So when I edit this assignment or project, Blackboard calls it an assignment regardless of what it is. There it is, due date. But when I was looking at this earlier today, I scrolled down here and I actually didn't shut off the submission until tomorrow morning. So if you're almost there, or if you got there after 9 this morning or whenever you thought the deadline was, you've got a little bit more time for this one. Okay? Let this be a lesson that you do not start these at the last minute. If for no other reason, then I can't be up all night long. And it wasn't on fire because people suddenly discovered it. It was on fire because everyone started at the last minute. So, in fact, the next project will be approximately the same in scope. Maybe it's different stuff, so I wouldn't say it's easier. I think there's a little bit less actual stuff that you have to produce for it. But the project after that, I don't think, so the third project, I don't think you'll be able to get out of that project with under 1,000 lines of code. And I don't care how good you are, if you wait to the last minute, there's no way, even if you know exactly the application you want to write, you are not going to crank out 1,000 lines of code overnight. Okay? So now's the time to discipline yourself. Another reason is once you get behind, all is lost because you cannot do, all these projects build on each other, so you can't do the next one until the previous one is working. Now I don't have a grading rubric up for this one, but I will tell you how it's going to be graded. It'll be roughly 50% for the shift reduce errors. If you have shift reduce errors, then you're going to lose 50% essentially. Get all of your shift reduce errors removed. All you have to do is type, where am I? All you have to do is type flex gpl.l. No. Oh, sorry. All you have to do is type bison. So there we go. And you don't have to add the options, but that's just going to generate the header file. So it doesn't really matter. You can lose track of it when you type make and a bunch of stuff scrolls off. So if you just run that by itself, if it doesn't comment, then you're in good shape. Otherwise, it'll say shift reduce errors. And if you want to identify those shift reduce errors, we did this a little bit in class and I posted it on Piazza. If you do this with the verbose, then it's going to produce gpl.output, which is basically going to tell you all the rules that it parsed and what it came up with. And if there are problems, it will tell you those errors right up here near the top. And then if it says state 205 has an error, you can search for state 205. And you can see, that's the if statement. So I must have had a problem with my precedence for the if statement. Right? The shift reduce stuff invariably ends up having the precedence stuff screwed up. So that's important because you're definitely dead in the water if you don't have that precedence stuff fixed up immediately before moving on. And then the other half is essentially divided evenly between the tests. And let me see, what do we have? 18 tests, 19 tests? 18. So I don't know. I guess each test would be what? Worth somewhere between 3 and 4 points, right around there. And then the other big chunk for getting rid of the shift and reduce errors. All right, so there's that. Last night I ended up changing course in what I wanted to do, and I ended up staying up the bulk of the night reworking Project 2 to confirm that I wasn't going to force everyone to bite off more than they could chew. Here's the thing, is that you all are starting to come into your own with being pretty fluent, good programmers, but there are a lot of bad habits that you all have just simply because you haven't been taught the right way to do things. So, by a show of hands, how many people are really comfortable with initialization lists? And if you haven't heard of them, don't raise your hand. Who's comfortable with them? 1, 2, between 1 and 3? How about unions? How about constructors in unions? Singletons, shared pointers, unique pointers, basically the smart pointer stuff, overloaded operators, like the left shift operator for overloading output to see out. All right, more of you are familiar with that. So these are the things that I want to start using. One of where the smart pointers come in is that when you get to writing stuff for this, we've already got a lot of memory leaks in our code just from Project 1. If you did you parse like a string constant or an integer constant, I guess it was a string constant, right? You would deal with YY text, and then you would create a new string and assign that to the pointer in that union. And so that was something that was allocated dynamically, and it was never released. And we actually haven't talked about what code we would need to release that on the other end. So by the end of Project 2, I want to have everything tricked up where we can use some of these more advanced concepts appropriately and have applications that are not leaking. And then these other topics touch on them in one way or another. So let me see, how do I want to do this? I don't have, because I started looking at this, I didn't finish the write-up for Project 2. I'll try and finish that. I'm probably not going to finish it tonight. I'd like to finish it tomorrow. But anyway, before the bulk of the weekend is gone, I'd like to have the write-up up, and no pressure, but give you an opportunity to start cranking away on it. I can give you a bit of a preview as to what it's about, so you can start thinking about it. And this preview works best if you get your working Project 1 in front of you. Let's see if I have it. Let me also give you some debugging tips. You're starting to figure out some of the strategies for debugging. You've got that VD tool, that VDE tool for examining differences between your output and your error output, between what's expected by the test and what your GPL program is producing. And you're probably also getting familiar with how to run these tests individually, where you just name your program, and in the test directory you can take a test and run it all by itself so you can eyeball it for yourself. And test 12, of course, was designed to have an error, so that's what's being reported here. So that's helpful to be able to do those things. Let me give you another, which is you want to do a quick and dirty test, but you don't want to create a GPL file for it. So for instance, maybe you want to create an integer I and assign 5 to it. So what you can do is printf is, it's of course a function in the C language, but there's a shell version of it that's been created for those who know and love printf. You can just dump text in here. So int x equals 5. Maybe I'll put it a new excuse me. Let me do double quote. I think I'm not sure if the new line is going to be captured with single quotes. Let's find out. Floats. We don't have floats in this language. Semicolon. Let's see what happens. Yeah, okay, good. I get the new line. All right, so what I can do is I can, on the command line, I can quick and dirty create a little test that I can put into GPL. But the problem with GPL, though, is that GPL expects a file name. So you can fool it by taking your printf statement and you can pipe it into this program. Now that isn't enough for it to work. GPL is still expecting it to come from a file. So you trick it and give it a file name that it doesn't really know what it is. And in the dev directory is a special file called standardin. So what happens is the pipe basically takes this executable and makes standardin come from the output of this, right? That's what you get when you do stuff like ls pipe into sort. Is sort normally takes input from the screen, but when I put it, let me, a little low here. But when I pipe it, then sorts still thinks it's getting it from standardin, but in fact what's happened is the shell has rewired the standard output of ls to be the standard input of sort. Likewise, with this little trick right here, we are forcing the input standardin of GPL to be the output of this program. Now GPL isn't looking at standardin, but it's going to open up this device, which is standardin. So it thinks it's opening up a file, but in fact it's getting the contents of that printf statement. And I can introduce a bug in there just so you can see it work. Like if I say, if I do that, some uppercase letters, there's no such thing. And then I get a syntax error. All right. So that's nice for quick and dirty testing for you to do. Just throwing that out there. It will come in use fairly quickly. So let's write some simple GPL programs. I'm going to use printf rather than creating a separate GPL file. Int x, float y equals 3.14. What? Huh? Oh, damn it. Double. All right, that works fine. So let me try something else. Or you try something else. Let me put this at the top of the screen. Let me actually just print it out. So there's my program. Is that good code? It's not, because I'm doing a redeclaration of X. Give it a try. Pipe it into your GPL. And again, if you're a little put off by this little standardin technique, you could always enter these two lines in a GPL file and then actually run it the good old-fashioned traditional way. Let me make that a bit bigger. And let me give you another one to try. Well, what's the verdict? Do those things work without error? They do. And this is like an awesome language. You can't make it go wrong. All right, this is the language 111 students have been dreaming about. Yep. Looks like no errors at all. Worked just fine. So, why? Why is it working? All right, so there's work in the parser we still need to do. Yeah? Well, let's take a look at the parser. Where the question is, looking at, say, let me get my other lines. Let me clear the screen. Yeah, this one. Let me not pass it. Oops. So these aren't trick questions. In general, what are we doing 2 times? You were assigning it, and even, let me get rid of the assigning. Now what are we doing? We're declaring variables, yeah? All right, so here's the question. Where in the grammar do you declare variables? Variable declaration. And that would actually be variable underscore, and there it is. So variable declaration, it says, look at this first one, simple type, TID, optional initializer. Now hopefully TID should immediately be familiar to you. That was, you would basically look for valid variable names, right? It begins with an underscore or a letter, and then anything that follows is a letter, an underscore, or a digit. So that's what TID is. Simple type, we can just see right here, there's a rule right here. If it's tint, tdouble, or tstring, it's considered a simple type. And if you recall, these would have been provided, they looked kind of like this. Right, we had these kinds of lines. I won't bother with the string one. So that means that this rule right here would be something like double TID, which might be X or Y, and then optional initializer. So let's follow an optional initializer around. It looks like, oh, it's on the screen here. T-assign, we know that that's an equal sign, and then an expression, which goes a little bit deeper if you start parsing apart expression, but needless to say, a single number is a valid expression. Did you all know that a single number is a valid expression in C and C++? What is a statement in C++? An example of a statement in C++ is an expression followed by a semicolon, yeah? Did I do this in this class? Don't laugh at me. Why is this not highlighting?
Yeah.
Oh, crap. All right. It's the Piazza ache is what you're seeing there. So that's a number. That's a valid expression. I can put a semicolon on the end of it, and that becomes a valid statement. There it is, G++. I wonder if there's going to be any sort of warning here. There it goes. Not very useful, but it's perfectly legal, right? So this grammar here we have for GPL is pretty faithful to C and C++ with the idea of what an expression is. So how are we going to, in general, fix the issue? Here's where we say, again, we say int x or int x equals 5. That's going to match this.
List of IDs.
Say it again?
Keep a list of IDs.
Keep a list of IDs, yes. And so what kind of code? If I again, you just use curly braces, right? And you can have actions associated with these. We've been having really simple small actions here. I guess a couple of the regular expressions were a little more involved, but we're basically going to have pretty soon we're going to have dozens and dozens and dozens of lines under a single rule because you need to do a lot of stuff. But what you might do is check to confirm that TID is not already in our list of IDs. Yeah? And how do I access TID? Here with actual code, so I'm doing clever code, and now I need to pass in TID. I can't do that. What goes in here? To get this. And what I'm interested in, this is the token. I'm not interested in the token. I'm interested in the semantic value, right? In this case, when I had x and y. So how do I get x or y? $2, right? This is $1. It's everything after the colon. $1, $2, $3. So clever code to confirm. I pass in $2. And if it isn't there, I add it to my list. Yeah? All right. What is this one as far as the dollar stuff goes? Dollar. Yes, absolutely. That's exactly what it is. So there, you may ultimately want to, not in this case necessarily, but want to assign something to $. You have some sort of expression in here where $$ is equal to some stuff you do. A really good example of that is if we go to the arithmetic stuff. So this is wrong, by the way, but I could say $1 plus $2, and I want to assign that to $. Right? So you have that kind of thing. We won't actually do that there. We'll be doing something different, but that's the general principle at stake here. All right. So that list of IDs is what is actually called a symbol table. It's a table of all the symbols that you have in your application. And traditionally, and as far as what you know right now, and what I know right now for as far as that goes, is that this language only has global variables. Remember, you have to put all your variables at the very beginning. That's it. There are only global variables, so there's only a single symbol table. In a more complex language, such as C or C++, whenever you enter a function, basically whenever you enter a new set of curly braces, it functions as a stack. So looking at the C language, or C++, anything I put up here is going to go into the global symbol table. The minute I enter the main function, I guess, so we have the global symbol table, and then when I enter main, where do I want to? I think I'll just like put this. I want to represent it as kind of a stack. And then when I enter main, then I have main symbol table because of this kind of thing. Int x, int x. Is that a bug? Let's try it. Well, as far as the language is concerned, it's all right. And what's happening is x is, in essence, hiding this. And why does it work? But why does that work, and why does this not work? Right? Because if I do that, and just to be clear here, let me comment that one out. That doesn't work. So why is it that the one works and the other one doesn't work? They're in different symbol tables. Right? The line 3 is in the global symbol table, and line 6 is in main symbol table. So when you're checking to see if it's legal to do, what you have to do is you have to see if it exists in the current symbol table, and you don't care about any of the other symbol tables. However, that isn't true of all things, because let me get rid of that line. Now let me say x equals. X isn't defined in main's symbol table, is it? So what happens is when you need to refer to a variable, you actually have to rifle all the way through that stack to the first instance where you find it, and once you find it, that's the one you use. Or if you don't find it in any of the symbol tables, that's where you get a not declared error happening. Okay? So one thing I want to do this semester, and we'll be breaking new ground with it, we won't be doing it with Project 2, but a little bit later on, assuming I can confirm that it's going to work okay, is I want to introduce local variables into the language. Everyone before you has worked with just a single symbol table in the GPL language. I want to make it so that we can have a stack of them and we add them on and take them off. And I think it's a relatively modest code change. That's part of what I was doing last night, was assessing the veracity of it. And last semester I did force a lot of changes to this grammar as we were going, and so I think it's primed and ready to just add a couple simple things. We got local variables in there. Anyway, nothing to worry about now. That's just somewhere where I'd like to take us a little bit later in the semester. All right. So what Project 2, and again I don't have the write-up ready yet, is Project 2 is you'll have to create a symbol class. Let's talk about the symbol class itself. A symbol class would be would create objects for each symbol I have, right? So I would create a symbol object from the symbol class for this variable. What kinds of, let me see, I guess I should let me call this symbol notes. So what if this was a class you were writing, what kind of information do you think you'd need? Yeah, the name. For example, X. So let's come back to type in just a moment. And in addition to the name and the type, so we'd have X and it's an integer. What else? The value. The value. All right. And what kind of thing do you think a value is? Yeah, absolutely. A union of all possible values. Now let's pick one of them. Well, no, let's not pick one of them.
All possible values or all possible types?
Excuse me. Yeah, it'd be all possible values will be here a while. Thank you. And then another piece of information we need is, what do I want here? I want this one. So what we're dealing with in essence is what a symbol would need to capture 176. What's an additional piece of information that we need for 177? The expression, yeah, what is the expression representing in this variable declaration on 177? The size of the array, right? So your symbol needs to hold what it is, the kind of thing it is. So x is an integer. Its value, so the actual integer value, like 5 that it holds, are 39, 538. And then so a symbol, if I say I have x, x could either be an integer or it could be an integer array, or a double array, and so on and so forth. And given that, let's look at it if it's an array. So if it's an array, what is the, let's say it's an array of integers. So what should the type be? Well, you can't store an array in an int. An int, yeah, pointer, right? So you use pointers for all this stuff. So that's what we'll be doing. We will have, so that the class will have these 4 as private data. And let me go ahead and talk about the type for just a moment. Actually, I don't know if it was in here. Nah, it wasn't dumped in here. All right, so let me so the, part of what you'll get with the Project 2 write-up are a couple files, and that is GPL type. There's an H and a CPP. Let me look at the header file. So that type variable is going to basically be one of these, meaning that I'd have class symbol, private, and then at some point we'd have GPL type, and then it would have this in it if it was an integer, or it would have this in it if it was an integer array. All this stuff we'll be looking at in more detail. I'm just kind of whetting your appetite and giving you a good feel for where we're going with it. So you'll be getting this file. It also has, I always forget to talk about it, so let me just plant the seed in your head. One thing you have to do is the error messages mention the type. Like you tried to declare a double X. It was previously declared as an integer. And so you need a way of converting these enumerations. Recall that enumerations are just integers. You have a way of converting these enumerations to the text equivalent of it for the sake of the error reporting. And there's this nice function right here where you just give it the type. And we can actually look at that. GPL types.cpp. And you see what it does is it just is a big, huge, nasty switch statement that if you pass in this enumeration value, it returns a string int that you can then use in an error message. So keep that in the back of your head. There is a function to convert types to their textual string equivalents for reporting purposes. All right. So there will be a symbol. There will be a symbol table, and this is the thing that's going to be the unordered map. And there will be a symbol handler. This handles the stack of symbol tables. And stack implemented as vector. Anyone want to hazard a guess as to why it's a vector and not a true stack internally? And it has to do with when we're...
You need to look at it. What's the bar at the top?
That's right. A stack has no way to index through it and look at elements other than the very top one, whereas a vector, of course, we all know you can iterate through the thing. So we use the vector as a stack. We push back and we pop back. But when we need to find whether symbol X has been declared, then we're able to rifle through all the tables looking for it. right? So that's the reason why it's implemented as a vector internally. So this is going to be the new thing that we'll do. When we do project 2, there's only going to be one symbol table. It'll be the global one. But we're going to set everything up so that it'll be trivial to then add additional symbol tables to it. Okay. All right. Call this P2 preview. And I'll do that because it looks pretty. All right, so let me shift gears now and talk. Let me start with initialization lists and a rationale for their existence. I wonder if I have it. No, I don't. There we go. Now I do. All right. Let's create a class. Let's see. Let's give it a name. I don't know. What's something that has 2 integers? Oh, let me see. Is that what I want? Let me think about this for a minute. No, I want this one to have a string. I'll call this. We'll do name. How about first name, last name? That's private. Public. And then we're going to call this then name. I'm feeling real creative today. We create a constructor for it. It takes a string fn and a string ln. And then what we end up doing is we do this. We add that. And we say that fname equals fn. Last name equals ln. And now let me create a class called, let me put an error statement in Sierra in name constructor. Create another class. We'll call this class family. And the class contains daddy, mommy, child, all right. There's always a bad one, right? There's a constructor for this, family, name.
What's up with that first semicolon?
That's just, it's the Piazza hands. So it's a variant on jazz hands. Name, mommy, name, child. Oh, God. TOWSNBM. Okay. Let's write that constructor real quick. And I'm going to do a quick 4YY, P to paste, get rid of those. And I say equals D, M, C. I don't want to retype that. Let me just go there, get rid of that. And let's put a see error in family constructor. All right, let's see what we got here. Let's create a family. Oh, criminy. I don't know if this is such a good idea. Name. All right, we're going to get uncreative here. A is Bobson. It's the Bobsons. You can't disown him, he still has your last name. He or she. And that's C, D, F, A, B, C, D. I think we're all ready for this not to compile. It isn't going to compile. Anyone want to tell me why? And the reason is because of line 6. It isn't because there's anything syntactically wrong. I don't think there's anything syntactically wrong. I didn't intentionally put syntactic bugs in here. But a combination of having line 6, and then by default 12 through 17, but having line 6 and having, I guess, lines 23 and 26. And you get to see the fireworks on line 29, I guess.
Tries to construct the family with default values.
So here's the deal. In 111, hopefully you had classes. In 111, you would create things without any problem. Here, it will not let you create names because if you never create a constructor for a class, the compiler will write a constructor for you. It'll write a constructor that takes nothing. The minute you write your own constructor for a class, the compiler no longer writes that for you. What that means is line 7 is the only way you're ever able to create a name object, meaning that if you do not provide 2 strings while in the process of creating a name object, you're just simply not allowed to do it. Now the reason this thing doesn't work is let me find the first error. I always want to look at the first error of these things. No matching function call for a default constructor. And it's, interestingly enough, it's pointing the finger at the closing parenthesis of the definition to the family function. It says it's expecting 2 arguments and none were provided. Then there's a bunch of other crap that's not worth looking at. You just look at the first error on all this stuff. So let's pretend for the moment that there's like a display function for this. Now my question is not whether that's going to print useful information, but would anyone challenge me that that is a legal line of code for me to do on line 33? Or let me really drive the point home. The very first character coming out of the blocks of this constructor definition. I'm sorry, not D. I meant daddy. None of you had a problem with 34, right? In fact, let's forget about this display. Let's run with this right here, right there. no one's going to challenge me and say that that's not legal. So the assertion we can make is by the time you reach the open curly brace, daddy already has to exist. Yeah? Which means if it already exists, that means it was already created. And we have already seen that the only way to create a name, remember daddy's a name, the only way to create a name is by giving it two pieces of information. So there's a special syntax provided to allow you to initialize, that's why it's called an initialization list, to create and initialize your private data. And the syntax for it, so I'm actually going to change up this constructor a little bit. What I'm going to do is I'm going to, let me show you the syntax for it. It is between the end of this parenthesis, that's why it was freaking out here on what's now line 31, it was line 30. I'm on column, I'm way over here. It's freaking out because it's right at this point that you see the initialization list. Now we know that spacing is really flexible in the language and you can put it right here. I like to just start it on the next line unless it's a tremendously short function just for my eyes. And then the next thing you do is you name all the private data. And we can see the private data is on lines 25 through 28. So it's daddy, and you parentheses and comma, mommy, child, and now I got to do this. He's always this way, making me mad. Right. That's the first step in doing the initialization list. You list all of the private data with empty parentheses. The reason I'm saying that over and over again is I get a lot of this. No, that's not a private data. I don't even have to say private. That's not a data member of the class. That's the name of a type. All right? Don't put the names of types. Put the names of the variables that are data for the class. Next, you have to fill these in. Now we know that we need to provide two pieces of information, a first name and a last name for each of these, so I actually have to change up the function a fair amount. And I think what I have to do is abandon this method of creating the family and go to a different method. So what I'll do is, yes, we'll talk about copy constructors in a little bit. And I'm going to put these on different lines just so, let me see, how do I want to do this? 3yy, paste. Those become commas. And then I'll make it all look nice. All right. So you can see that what I have here are 8 arguments to this function. 1, 2, 3, 4, 5, 6, 7, 8, and that goes away. So there are my 8 arguments to this constructor, which means I have to go here and change this to something horrendous like first. These are now strings, right? String, first name 1, string, last name 1, string. Yeah, and now we do editor tricks. And there are commas after these 3, and that one ends. And I'll leave it like that, a little more readable. And I have to take these same 4 lines, and I have to go down to this definition here and paste them in. I'll leave it like that again, no semicolon. And then there's my initialization list. All right, now I'm ready for step 2. Put in the arguments. fn1, ln1, I really chose a terrible example for all this. This is just crazy. All right. And then these are 4. Whoops. These are 3, 2, 2, 3. So now those 4 pieces of data are created via the initialization list, and I'm able to provide the arguments to them, right? So I can call that 2-argument constructor that is part of the name class. I guess I should try it. Now all this becomes unnecessary. So this stuff is 111, 211, 311 type stuff right here. You don't do that anymore. I'll leave it there as a lesson for others. And then these go away because I just put them all in here directly. Alright, so I should have all that. Let me make sure I don't have any weird stuff in here. Leave that in. Oh, let me bring this up. I'll do it over here. G++ standard equals, we go for the latest and greatest. And this, what was this called? Oh, I'm in the wrong directory. 2019 02 22. Nope, 21. No input files. Oh, first try. Doesn't do anything. Oh, it does. I forgot about that. I put those error messages in there. So it's calling the name constructor 4 times for the 4 names, and then the family constructor, right? Here's the thing is, there are reasons for doing it that go beyond simply making it so that we can call this constructor, because what you could have done before I did all that editing and changing of the call to families, I could have done this. I could have created, in fact I just make it empty, not do anything. I could have created a default constructor, and then after creating that default constructor, I pass the 4 names in like I originally did, and then I do the assignments down here. Now, why am I against doing that?
That would allow someone to exist without having
Right. Okay. So there is an argument to be made for that. And that's a good argument. The reason I gave you, in the fact it's the motivation for removing that default constructor as soon as you write your own, is the language designers are saying, if you create a constructor, then that means, by golly, you know exactly how you want objects created, and no one should be allowed to create an object any other way, because it has the nice side effect, since you wrote that constructor, you can ensure that every name object ever created is always created validly. Right? So then the name doesn't have any valid value. Now, this is a discussion about what are the application requirements. Is it valid to have a default name that has John Doe in there or something like that, right? And that's a discussion you have with the other software engineers and maybe with the customer and so forth. But when it comes right down to it, you do have the capability of forcing people to use classes your way, and that they're never allowed to create an object if it isn't valid, by controlling what constructors they have access to. So that's one argument. But there's another argument to be made, which is regarding efficiency. So we already decided that, so let me introduce that by looking at this equal sign. For every class that you write, there is an assignment operator that is created for you if you don't write it yourself. Did you know that? So we didn't write it, but the compiler did provide a name reference operator equal const name reference n. So that is provided for you, and you can go ahead and write it. What's it going to do? It's going to say this first name is equal to n dot first name, and you do the same for last name. Okay, so that's what the compiler does if you don't do it yourself. So keeping that in mind, we had, when we hit this line here, with these ones I commented out, we all agreed that these variables already exist. So four constructors had to be run to get to line 51, right? We're looking at the scenario where I create a default constructor. 4 default constructors did run because they did create those 4 objects. Next, 4 more functions are being run on lines 53 through 56 because the assignment operator is always a function. So now we have 8 function calls. And there are about 30 million families created every hour on this application. So now instead of, whatever, 30 million function calls, I got twice that. But it gets even worse because what I had here is I had name, D, name, M, right, these. Everyone remember from 111 pass-by-value semantics, where the arguments are their own variables? Those variables are actually created. Well, if these variables here on line 42 are actually created, a constructor had to run to create them. So that's 4 more functions. Now we have 12 functions. And so the argument for an initialization list is you reduce the overhead of all the functions that you call in order to create and initialize these things. Because the overhead does get real. We're talking about a simple toy class. You get into something real like a compiler or whatever application you're doing. You have classes within classes and hundreds and thousands of these things are being created. The overhead does get real in wasted function calls that you have. So it's very much a thing of optimization. Let's look at this. We can improve on what we see here. String is not a built-in type of the language. It's like int or double. And you can see that with the editor syntax highlighting. If I type int or double or char, they all turn green. But if I type string, it doesn't. Why is that? Let's say it again. It's a class, which means someone wrote it, right? Some software engineer wrote it, and they were lucky enough that it became part of the standard. Well, if it's a class, then what has to happen on lines 47 through 50? There are 8 constructors running there because you have to construct each of these. Remember that it's passed by value, so you get a copy of it. So there is a constructor running. It's a copy constructor, and we'll set that discussion aside for the moment. But that's inefficient. So how can I avoid, let's look at, how can I avoid a constructor being called for fn1? Pass by reference. Right? So what you want to do is put a reference symbol after these. It doesn't change the way you call it. It only changes where you declare it and define it. So I actually have to put it up here. Let me see. Current line, the +3, search for G, replace with G, ampersand. There we go. Doesn't change. Again, this doesn't change at all. These are C-style character arrays. These actually get promoted to strings, which means constructors run to create temporary strings. But those temporary strings then come in here. fn1 is actually just another name for that temporary string. It doesn't create a whole new variable. That's a little bit dangerous. That means that, let me get rid of the temporary string on one of these. I create a string, fn1, Bob, and now what I do is I pass in, let me call it first, I'll just spell it out. All right, with what we were talking about a couple minutes ago, fn1 on line 17, excuse me, on line 47 is a copy of the variable that we created on line 65. So a constructor ran to create fn1 on line 47. By adding this, fn1 is no longer its own variable. It is merely referring to a variable that already exists. So in that case, 47, fn1 is now merely referring to first name. The danger in that is I can do stuff like this. Assuming that function exists. Right now, in the old C pass by value world, who cared if someone did that? That's just screwing up an input parameter that no one who calls the function cares about. But now I can do real damage to anyone who calls my function. And so what I need to do is I need to make a promise to those people that I won't change their function, or that I won't change their object by making this const. That's a guarantee to the compiler, right? The only difference is whether or not your program compiles. It all runs the same. It's a guarantee to the compiler that you will do nothing that tries to change fn1, and if you do, it won't compile. And here I'm trying to do something that changes fn1, so the compiler would hang on this line and not compile. So this is kind of the end of the story for parameters that are of class type, string, date, family, name, symbol table, symbol. If you're passing it into a function, you pass it by reference to save on function so that you don't create new ones. Second, if the function is not designed to change it, then pass it in by constant reference as a guarantee that you promise not to try to change it. Because if you do, it won't compile. So that means that all of these do that. This is something that will set you apart between if you start your first job programming C++. This is going to show you as being a seasoned developer, not an amateur. That you understand the difference between pass by value and pass by reference and the guarantee that const provides. Okay? Initialization lists. We don't really need them for integers, or let's say floats. So let's say that the family class has a float. I don't know, the family's grade point average. This is a built-in type. There is no constructor for it. If I wait and I just do this, that's fine. However, there's something to be said for consistency. Oh, it's hard-coded in there, which is fine, by the way. Even though I don't earn anything as far as optimization on line 56, oh, there's no semicolon, it is consistent with every other piece of data in the class. So here's the general rule, and this is what I'm going to require for everything you do from here on out. I have to think if there are exceptions. I'll talk about the exceptions in a moment. If it is a data member of your class, you have to create a constructor for the class, and you have to have an initialization list for all of the data of the class. If you do not have your data in the initialization list and you're doing this kind of thing, that's 111 amateur hours, what that is. Okay, don't do that anymore. The exception is occasionally it isn't as easy as knowing what the value is. You may have to go interrogate a database and get a response back, in which case you may not be able to put it up here. You may have to have some functionality down here to get a valid value for a data member. So there are exceptions, but by and large, whenever you're designing and writing classes, you should always be trying to shove everything into the initialization list. Okay.
So besides the exceptions, is there any other reason why any code at all would be in really great brackets?
Yes, absolutely. There are all sorts of reasons, and I have to try and conjure up an example real quick. Yeah, maybe the class is managing, among the other things it does, maybe it's managing a log file and you have to go ahead and log an initial entry in the log file, right? I don't know. I don't like that example. It's kind of a lame one, but it's an honest one. There's always situations where you have to do some sort of algorithmic work in the constructor.
Can you put any code in the initialization list?
Any legal expression can go in the initialization, not in the initialization list, as the argument to the data member. Any legal expression can go in there.
5 plus 10, that's fine.
You can do 5 plus 10. You can hard code 3.14.
So I can do like a function called lookup.
Absolutely. So if you want to abstract all that database lookup into a function, you can just put database function call here. And whatever's returned would initialize GPA. Of course, you would want it to be returning a float in this example. Yeah, any legal expression. All right. So I have more to talk about, but I think it's miserable for you to have to listen to me for 75 minutes. I think with the additional things I want to talk about, maybe I'll try and create some exercises or something to do that drives you to it, and then I can like do a debrief so that you're doing hands-on rather than just watching me playing Vim all hour long. I mean, don't get me wrong. When I go home, I just open up a blank editor and I'm, hey! But I know that you don't want to watch that. So for the remainder of the stuff I want to talk about, I'll try and offload that to hands-on activities, and then also look forward to some sort of write-up on Project 2 appearing before class meets next. Okay. All right, so thanks for hanging in there with me, and we will see you next Tuesday. Remember, you've got until tomorrow morning to submit that without penalty, and I don't want to accept it after that. So finish it up if you haven't and get it in.